All right, let's get started. This is evaluation engineering, iterative strategies to testing prompts. And I'll be watching the chat throughout this talk, so feel free to send in any questions, and I'll also spend some time at the end talking. But basically, the major point of this talk is to talk about evals and how do you test prompts. And I'm here to convince you that there is no one-size-fits-all solution, and we're going to do it iteratively. And the feedback loop is the best way to do this, and iteration is the best way to do this. So yeah, without any more intro, let's get started. My name is Zoneraich. I am the founder of PromptLayer. We are a prompt engineering platform. So what that means is we help you with all your prompt engineering. And evals is part of that, actually a big part of that. And probably the biggest buzzword in the prompt engineering community. So you can find me on Twitter or X at I'm Jared Z. We do a lot of updates there and engage with our users there. Our team is based in New York City, so if you're around, say hi. We have some in-person events coming up soon as well. We'll be doing an AI startup demo day, which would be cool. But yeah, we're the prompt engineering platform. We are where you come to build LLM products and to do prompt engineering well. And I want to teach you how to do one part of that today. So this is us. You can find us at PromptLayer.com. In short, we are a prompt management and collaboration tool. So what that means is you can create prompts in PromptLayer in our visual CMS. You can version them, you can pull them down programmatically, promptlayer.templates.get, super easy, basically one line of code. And you can have your prompt engineers, whether they're engineers or non-technical people. We have a lot of like lawyers and educators using our platform in conjunction with engineers, coming in, testing prompts, running evals, seeing how they work, and deploying them all from the dashboard without end releases. So let's talk about that eval part of it. So you have someone like a lawyer coming in and helping you build your legal AI product. How do you let them know if their new prompt broke the system or not? This is I think a very important part of the whole iterative prompt engineering process. So let me get into our PromptLayer philosophy to start out. I think in general, we don't like to take too many opinions. We like to mostly say, this is a new field and let's listen to our users, but there are a few opinions we take. And the first such opinion is one size does not fit all. You'll see a lot of eval benchmarking suites or eval, like downloads that you run it on some eval test set, or maybe this is a financial data eval or some insert fill in the blank eval. I'm here to tell you, ignore that stuff. That stuff is pretty good for evaluating how good your model is, but at least the target of this talk, and if you're watching this, I'm gonna assume you're building an LLM product and not building the LLM itself. So if you're OpenAI, if you're Anthropic, if you're Google, this is not that relevant. You should still use benchmarks, but for you, the benchmarks are not relevant if you're actually building a product. What you want to be doing is seeing if the product works and seeing if the prompt you built has good output. And that's why one size does not fit all. You're going to want to probably build your evals catered towards what you're actually doing. And you need something flexible to do that. And you also, you need to start thinking about it, and you need to, I guess that's where the iterative part comes in. And that's what you need to do it iteratively, because your users are going to change, your product's going to change, the AI is going to change, and you need to have a flexible eval that is very catered towards your prompt. And probably you're going to need one for every prompt you're doing. For example, if I have an app that helps me find what lunch to get to, how is a eval benchmark going to help me do that? I want to find if my users are actually going to the restaurants I suggest. And that's completely unrelated to these terms of accuracy, recall, whatever. Yeah, you could fit it into that mold, but I don't think it always makes sense, especially if your domain experts are not necessarily engineers. So that brings me to our second philosophy point. and then we'll get into it. Prompting with experts. I think one of the big learnings we've had at PromptLayer, we started as a product. We've been existing for a year and a half. I think we're one of the first prompt engineering platforms. And we began with a lot of indie hackers using our product. And from there, we moved on to real teams building domain AI, domain-specific AI. And what that meant is if you're building legal AI, you need to know about the law. If you're building an AI therapist, you need to know about human interaction. If you're building code-generating AI, you need to know about code. So that's why we say prompting with experts. How do you bring the domain expert into the prompting process, into the prompting and prompt engineering cycle? Because they're the ones who know if the output's correct or not. They're the ones who probably should be doing the prompt engineering. Probably, like if I'm building legal AI, I'm an engineer. I don't know anything about contracts. Why would I be the one seeing if the prompt is good or not? I wouldn't. And that's why these two philosophy points of one size doesn't fit all and prompting with experts is saying, can you loop in the domain expert into your process? Because the process is so tailored to what you're actually doing. This is not a general, when you're building general ML models, it's basically a cookie cutter way to do it. You kind of need the ML model, the training set, the validation set, but we're starting from first principles, building with LLMs here, and you don't necessarily need all that. And you more specifically just need domain knowledge and how do you inject domain knowledge into your product. So let's talk about kind of the triangle of PromptLayer and the iterative process. And this is not just PromptLayer specific. This is how do you actually do prompt engineering? We believe there's three main parts of it: the prompt template, the eval, and the data set. And they're all connected. And they're all part of this iterative cycle. So you create your first prompt, then you build an eval. And when I say build an eval, I mean build a pipeline that comes out to a quantitative or qualitative evaluation metric. And then you need a data set, because how are you running what are you running this pipeline at? You're running it on a data set. And then maybe you have it in the wild and you find some bad results and you add it to your data set. Then you're rerunning the eval. Then you're remaking the prompt template. As you see, it's all connected, and these are the three main principles we see in prompt engineering. This is just about how we use our platform. If you're using PromptLayer, you have observability here. You have, I guess, three main aspects of our prompt platform: are the prompt registry, which is the CMS, the observability side, and the evals. I mean, the three aspects, three sides of the triangle, right? Each prompt in PromptLayer, there's one click to add it to the data set, and then you can one click rerun the eval. And everything about our product is basically saying these three are interlinked. You need this whole cycle to do prompt engineering well. And we have a lot of teams who have non-technical prompt engineers going into these logs, seeing what it doesn't work, adding it to data sets, building new evals, prompt engineering, and going through this whole iterative cycle. And that's the iteration I'm talking about. So it's all connected. I think everything in this process, you can't do it independently. You can't just download eval benchmarks. You can't just download a data set, like a data set for evaluating my prompt. It doesn't make any sense. You need to hand create data sets for your specific use case, hand build the eval for your use case, and then hand write the prompt. Maybe an AI can help you do all these things, but they're all linked, and you can't think about one without thinking about the other. So I think the first thing, this is, I would say, is our goal. Our goal of building good eval iteration, our goal of building a prompt engineering dev framework is that we want to get to a continuous integration. We want to be able to get a GitHub action style dev framework where I can edit a prompt and I can instantly see if it improved or not. And that's what this is. And it does take some setup and some thinking and iteration to do. Here, this is a prompt I've made in PromptLayer that basically helps you explain stocks based on a RAG pipeline. And as you can see here, I have a few different versions with different scores. It started at 72%, Then I added function calling. I made a better system message according to the commit message. I got 76. Then I got 76 again when I lowered the temperature. It didn't really help. Then I switched to a different model, GPT-4 Turbo, and it improved a lot. So I'm sure it's immediately obvious how nice it is to have a number come back. And it's not always one number. Maybe you jump into it and you're getting 3 different numbers, or you're looking at actual diffs in the outputs. But continuous integration is the goal. So how do we get there? There's a few general strategies I'll talk about in this talk. The first one is backtesting. So basically, I'll describe it if you don't know. Backtesting is probably the simplest way to do eval. It's run your new prompt on old responses. So you'll see the triangle comes back and this iteration comes back. But basically what I mean by this is 3 easy steps. Log your results. So basically say you have your product in prod and users are interacting with it. Log those results, log those LLM calls, and now you have a data set. Now you have a historical data set. And all you have to do is run a batch using the new prompt and compare the new prompt output to the old prompt output. Pretty simple. Does this give you a score like this? You can get a score on how much it changed. It's not going to tell you if the new output's correct or not, but it's going to tell you how much it changed. And often that's important because remember, we're dealing with probabilistic tools. So every time you run it, it's going to be different. But if you make a drastic change to the prompt, you're going to see a lot more changes in the outputs. And then maybe you'll say, did I mean to do that, or was that an accident? So just to describe how you would do this in PromptLayer, I think what sets us apart is that we really think about this iterative prompt engineering process and trying to make this easy. So you already have your prompts in PromptLayer. Like I said, we help with logging the prompts. That was actually the first thing we started as a platform. You could go into PromptLayer, you could set some filters, whether it's by a tag, maybe you want to filter prod, maybe you want to filter a certain location, whatever. You could build, and then you could build a data set from the history here. You have 2 options. You could upload it as well. This is just a screenshot I took yesterday. And then once you have the data set, you build the eval. So how PromptLayer evals works is, and I think we're a little bit unique here, so I'll explain it, is that PromptLayer evals basically means we have an eval pipeline builder. And it's very flexible. You can have as many steps or as few steps as you want. You start with the data set and you run a pipeline on it. So in this case, I've made a little, what do you call this, a flow chart for the backtesting eval that I've created. The first 2 gray boxes are my data set. So in my data set that I've built in this last slide for my history, I have historical inputs. So the variables that went into my prompt context, date, location, weather data. This is a prompt to tell me what I should wear today. I have it run every day. I have like a Zapier thing going on. And then I have my old prompt response. So it's like the historical inference result. I have one step in my first step in this pipeline, in this eval pipeline, is to run the historical inputs through my new prompt. So maybe I'm changing the system message or something like that, or the model. All right, so I run the new response. And then my last step, it's a very simple eval, is I'm just doing a string diff between the old response and the new response, seeing how it changed. I can do vector comparisons as well if we want to get fancier. But I always say with these things, start simple. Complexity in LLM applications can spiral way out of control, and often it does. So I always tell teams, begin with the simplest thing possible and iterate. So the simplest thing possible is a string diff. As you see here, we see how it changed. Apparently it got the date got the time differently. It worded it a little bit differently. This is very interesting. This is the LLM is a black box for a lot of people. And I actually argue you should view it as a black box. And our goal here with evals is to give you some insight into the black box, give you a little observability, know if the new prompt is going to break everything, change everything, or not affect everything. So here's an example. So basically, this is our eval pipeline, and you saw in this screenshot, we have numbers. Each time I edit a prompt template, it kicks off an eval. This is the eval results. So as you can see here, it looks like a spreadsheet. We have our variables along the top-hand line. These are from our data set. Here's our new response. So a new response is right here, basically the new response we generated. And then here's the comparison diff. So true means the old response and the new response are the same. And then for false, it'll show the diff. So as you see here, 58% means 58% of our historical logs have been changed by the new prompt. And super useful. This is what a lot of teams do. This is basically step one of doing evals. It's the easiest step and gives you a lot of insight. You also get some cool statistics as well. So if I click that inspect button here, I'll see some stats for the time it took and the cost of the prompt. And this is super interesting if maybe you're running, instead of one new response, maybe I'm running 3 of them on different models and I'm trying to test out or different temperature or different versions of the prompt or who knows what I'm doing. Basically, I think that who knows what I'm doing is a very important statement here because there's so many ways to skin the cat here and there's so many different optimizations you could do. So it's important to enable everything. All right, what's the next strategy? Regression testing. So this is, I'd say, this is like a subset of backtesting. You could do it the same, you could do it differently. The main difference is instead of a general purpose historical data set, now we've specifically built data sets for edge cases and error states. So say I'm running my application in prod for a few weeks. I can then go into the application, find all the times it's failed, and build a data set around that. I can also, maybe I want to give a thumbs up, thumbs down to the end user and use that to channel into my regression test so I can see what's working. You can build regression tests with things that are working as well and make sure it doesn't stop working. So then you run the batch and then you compare the outputs, same thing. So let's look at that flowchart again. We have edge case inputs. So this is a different example, not the weather example. This is, we're taking in a user input and we're taking in user context. Pretty generic example. We have a ground truth. So in this case, the ground truth might be falsy or it might be truthy. Depends what you're doing with this regression test. Let's say it's the truth. So you have the edge cases that you want to test and you have the expected result. And then we're going to generate our new prompt response as we did before, and we're going to compare them. Maybe we're comparing a few of them. Maybe we're comparing on 3 different categories. For example, maybe I'm doing a string diff. Maybe I'm doing vector distance. Maybe I'm having an LM as judge. Oh, and there we go. We get more into this. How do you eval? How do you get that final score? So there's a few ways. This is not all the ways, but these are kind of all the primitives that you need to think about. String comparison, like I said, start easy. That's the easiest. Just a string diff. LM as judge. I'd say this is also pretty easy to set up. It's hard to get good. It's hard to make this reliable, and that's going to take a lot of tweaking. And honestly, you're going to have to do prompt engineering part of your eval engineering. Gets a little meta there. But LM judge as judge is another eval type where you're basically just using a prompt to say, here's the expected result, here's the actual result, are they the same? And tip I would throw in here, quick tip, is getting Booleans out of the LM is much more reliable, at least I've seen, than getting numbers. So instead of saying rate this 0 to 10, try doing true or falses and maybe do a few of them and add them up. Third eval type is vector distance. So we're going to create 2 embeddings of the responses and see how far apart they are. Super useful if you're trying to compare semantically 2 outputs. Like the weather example would be pretty good for that. Human input, sometimes it's best to just hire some human graders and let them put in comments, score things. And then also sometimes, and this is honestly the best eval. If you can do a deterministic eval, you should do it. So what I mean by that, let's say you're making a prompt to generate SQL. You can deterministically check if the SQL can run or not by running it on the database. And that's going to give you a real true or false. That's a ground truth. So most LM use cases don't have something like this, but if you do, go for it. And then I'd also add, you can add like traditional ML here as well, where you're doing some classification. So yeah, that's regression testing. That's our second way. And I see a lot of teams having prompt engineers also going through the logs and finding edge cases and cataloging these. And that's how you're going to build your edge over time if you're building an AI application. You're not going to build your edge by just like building version 1 of AI. Everybody's doing that. So you're building legal AI. I like that example. If you build something really good, you're going to stand out. how do you build something really good is you prompt engineer very well. You build really good data sets. You build really good prompt templates. And really good is very subjective to your target audience. And that's why it's really important to get an edge there. So like anyone can make a general purpose Twitter demo, but to make a product really good for your users takes work and it is hard. But you can build a moat for sure, because it's very hard to predict everything a user is going to do, and you have the data, so start using the data. So, okay, so general strategy is end-to-end tests. I like this one a lot. This is basically saying, build the data set of your inputs. You might not have outputs, and a lot of times you don't have outputs. So let's loop that into here. So build the data set of inputs. This could come historically, or you could just sometimes I'll just open ChatGPT and have it build me a CSV. Then run the batch, end-to-end pipeline. So run your whole thing. It could be like 10 different prompts. It could be a prompt, it could be RAG. This is very useful for RAG pipelines. I think that's what I'll show you. And then evaluate it. So here's a flowchart we got here. This is a RAG pipeline. So this is that stock investment AI that I showed you earlier. And what we're doing here is we have our historical inputs. So just a bunch of user queries. We have ground truth answers. So sometimes we might not have ground truth, but in this case we do. And then we're going to use the historical input in the first step of our pipeline and fetch the RAG data. So we'll call out to some endpoint. You could do this in PromptLayer, call out to our RAG endpoint, say, here's the user query, give me a JSON of the RAG data. And then we'll use that RAG data or the retrieved data and stuff it into the prompt context. So as you see here, the fetch RAG goes to the prompt response, as does the user query. And that's how we get our final result that we can then do an eval and compare to the ground truth, or just say, does the LLM like it? Maybe we're asking if it's rude. Maybe we're asking if it makes sense. Maybe we're just asking if it doesn't know. So here's an example of the eval here. As you can see, question and answer come from our data set. Our first step here is our RAG step. So it's sending the question to our endpoint and returning some JSON of basically like, what's a steel company is the question, something like that. And I return the matching JSON blob from our data set. And then AI answer is our generated answer from a prompt. So I throw all that information, not the answer, obviously. And then our AI eval here, this is LM as judge. It's basically saying, say you're a stockbroker and you're grading, or you're a teacher and you're grading exams. The answer is supposed to be NEU Corporation. And you got the answer, a steel corporation from North Carolina and then it probably has the name after that truncated. And you can see the full thing, obviously. Give it true or false. So that's where the 80% is coming. 80% of these are true, 20% are false. That's a pretty good quantitative score. Then what else we got? Okay, so this is another end-to-end test that I've compiled. This is basically this is actually an application I have locally that I use to ask questions to our own database. I call it SQL Buddy. But as you can see here, in my data set, I don't have the answer. I only have the question. So I have a bunch of questions, and I've compiled these by hand. Then my first step is a prompt. So my first step is the prompt that's generating the SQL query. I'm using function calling, as you see here. Don't have to, but I'm generating the SQL query for the question. So I could test that prompt, or I could test if that actually works. And does my application work end to end? So the next step, I'm sending the SQL to an endpoint, actually running it on a database, and I'm getting the output. And so here's the output, and then I'm stuffing it in another prompt and getting the answer. And then we're using an LLM again to evaluate it and saying, does this answer the question? So as you see here, first it says, I apologize, so it's going to be a false. It doesn't answer it. And then the third one here is true because it actually got the answer. The second one, SQL failed, so it's false. Anyway, we don't have to go too in depth here, but end-to-end tests are going to be super useful. Just like when you're coding, you want unit tests, end-to-end tests, you want all of them. And this is the only way to actually see, does your system work? Otherwise, you're guessing. There's a lot of randomness to these things. So here's a tip that I'd like to throw out. Single prompts are easier to test. Try to do single prompts when you can. End-to-end tests are great if you have 10 different prompts, but Unit tests are even better. This is a cake. If you come to our events, you'll get some cake. So single tests are easier to run. How do you do that though? The prompt router architecture is a good way to do that. So as you see on the left here, this is kind of a naive approach to building a chatbot. You have your prompt, maybe I have some few shot examples. I have a user message, then I get the AI one, then I tag on the user, then an AI. That's pretty good. Kind of hard to test, especially if maybe I'm then running SQL and doing something else. If I can split everything up into modular prompts that can be tested individually, my life gets so much easier. Testing gets so much easier. I still might want to end-to-end test, but I could do unit tests now. And anyone knows, as you know, unit tests, easier to understand, easier to write, quicker to run. So here, I'm going to use a prompt router, which is it's going to be its own prompt, most likely. You could also use maybe a traditional ML model or something deterministic, but I'll use a prompt router to determine if I want to send it to A, B, or C. And then it's as simple as just running one single prompt. And it basically takes a variable away from our evaluation, which makes everything easier and more reliable. So in this case, this is an eval I created. You can't really see it. It's a little small for the prompt router. So this little diamond here that basically takes in a question, takes in a category. In this case, it's the ground truth category, and then uses my prompt router prompt to give me what category it predicts it, and then the eval compares the two. Just a simple string comparison. As you see here, I can do pretty well. It's very specific. The more specific you are, the better the model is. I can get to that 97% score, and I could keep it there because I don't have to juggle 50,000 things my prompt has to do, and my data set could be cleaner. Just the mental bandwidth I need is much lower. So yeah, just going back, this is the iterative cycle of prompt engineering. You build the prompt, you build the eval, you build the data set, and you think about how to do these things better. Maybe I've built this master prompt that it works pretty well, and then I want to do better, and everything's getting confusing, so I'm going to break out the architecture. And I'm going to iterate. Maybe I'm going to iterate back, and maybe I'm going to combine B and C. And basically, I think with a lot of these things, don't think about it too much. Just try things out and build a dev environment where you can try prompts out and get results pretty quickly. So yeah, this is PromptLayer. My name is Jared Zoneraich. Check it out. Our platform is meant for prompt engineers, meant for people building LLM products, and meant for people who want to do it as a team collaboratively. So I'll send a link here in the chat. And you can check it out there. You can contact me at jared@promptlayer.com, or you can contact me on X at I'm Jared Z. I hope this talk was helpful for you. I might stick around in the chat here for a minute or two more, so feel free to send in any questions if anyone has. Thank you.